Hello, so today we're going to go over forces in the four parts, the four different types of force questions that we can encounter on the AP Physics C test, okay? So first we're just going to start with the basic, okay? So first of all, let's just go over the steps here. So our first step is going to be free body diagram, okay? So this is where we draw our box, we draw and label all the forces, so it's something maybe like Fn, mg, maybe an applied force, and then maybe we can have friction as well, okay? Remember, when you're on the AP test, you're drawing a free body diagram for points. Do not break something into components, okay? That's really important that you're not breaking something into components. You can draw it again for yourself later, off to the side, but for points, you cannot break it into components. Step 2. The second step is to have an XY chart. So for here, we have something like X, Y, so I have forces in the X direction, forces in the Y direction. So the forces I have in the X direction are FA and FF. FF needs to be negative because that's in the opposite direction. One of those needs to be negative. And then in the Y direction, I have something like FN, and then I'll have minus mg since mg is down. So here, I'm setting my axes like this. That's positive. Mental note, you should try to always make the direction of acceleration as positive. That's actually a really important thing to do. That will definitely help you with problems. A is positive. Okay, then step 3, we're going to set up our Fnet. Okay, our Fnet equals ma. So what we need to do is put the sum of the forces in for our Fnet. Okay, so for example here we know that Fy is just going to equal 0. So our Fx is going to be our Fnet. So I have something like Fnet equals Fa minus Ff. Okay, so those are sort of our basic steps. So one last thing to remember about your Fnet is that if we are given something where we have, well, let me go ahead and I'll give you an example. So I got something like this. I'll have 100 newtons, 140 newtons, 50 newtons, and 20 newtons, okay? So I already got the free body diagram because that's my free body diagram, so I'll make an XY chart. So in the X direction, I have a positive 50 and a minus 20, okay? And then in the Y direction, I have a 140 minus 100. So my total in the X direction is 30, my total in the Y direction is 40. Now you notice in this example, unlike the first example, we know that neither one of these is equal to 0, right? Both of these give us a number. Okay, so what that means is I have something that looks like this. I have my box, I have one force that's this way. Let me just redraw this. I have one force that's this way, that is 30, and then I have one force that's up, and I need to find Fnet, right? And so in this example, I just need to use Pythagorean theorem and find this part right here. So this will be Fnet, okay? Fnet is sort of the Fx squared plus Fy squared equals Fnet squared. So if I don't have a 0 in a particular direction, I need to use Pythagorean theorem, or you can think of it as the distance formula to find that sum of the Fnet. Okay, now if in this question it says find A if m equals 10 kg, so I have Fnet equals 50, right? I'm going to plug in ma for Fnet, so I have 50, or ma equals 50. I'm going to plug in 10 for m, so I have 10a equals 50, and then I have a equals 5. Okay, now think to yourself, what mistake have I made here on this question, on this answer? Hopefully you remember to write units. It's really important to write units. It's easy to lose points on that, but that's a really disappointing way to lose points because all you got to do is write it down, and that's potentially a point you're getting, right? Okay, so second type, we have inclined planes. Okay, so these are really important to know. They're pretty frequently coming up, and so let's go ahead and look at this. So I have an inclined plane. It's going to be theta. I have my box here of mass m, okay? And it's going to say surface is smooth. Find acceleration. So on a question like this, remember the two clues that we can have that something is a force question. So is this a force question? Okay, 1 asks for acceleration. Okay, so that's an excellent clue that something is a force question if it's asking for acceleration, or asks for specific force. Okay, so if it's asking for what's the friction force, or even what's mu, right? Or maybe what is the tension, or what's the normal force, right? That's almost always a dead giveaway that it is a force question. Okay, so asking for acceleration or asking for a specific force. So we have our inclined plane. Our first step, remember, going back to our steps, our first step is free body diagram. Okay, so we go ahead and add our free body diagram to this. So I have mg straight down, and because it is smooth, remember that's a really important word, smooth, that means FF is equal to 0. There is no friction in that particular question. So I have smooth, so no friction. So I'm only going to have 2 forces. I have mg, and then the other force is, hopefully you knew that it was the normal force, so Fn. Okay, now if that was the AP test and I was drawing the free body diagram, I would put that down and leave it, nothing else. Okay, but I also want to break this into components. So I have this blue component here, and then this red component for mg. So when we're doing inclined plane, we want to set our axes parallel to the inclined plane, so x, y. This just makes it a lot easier. That means that I only need to break mg into components. I don't need to break anything else into components. So my red part is mg, and then this is actually going to be cosine theta, and then the blue part is going to be mg sine theta. Remember, sine usually goes with x, sorry, let me change that, usually goes with y, and cosine usually goes with x. But in this case, in inclined planes, it's actually going to be flip-flopped, okay? So usually sine goes with y and cosine goes with x, but in this case, it's flip-flopped, so we have mg sine theta. If you ever can't remember, just think about what happens to sine theta when theta is 0, right? So if I have a theta of 0, sine of 0 is 0, right? And that actually makes sense, right? As this inclined plane sort of rotates down to become a flat surface, this mg sine theta is going to go away and become 0, okay? So mg sine theta, that is the force down the inclined plane. And then we have mg cosine theta, which is the force into the inclined plane, which gets canceled out by Fn, okay? So it says, find the acceleration. So I'm going to make an xy chart. In this case, you don't really need an xy chart because the Fy is just equal to 0 because it's not going into or out of the inclined plane. And then Fx is going to be my Fnet. Okay, but let's go ahead and write it down just for practice. So I have Fn, and then I have minus mg cosine theta. And then in the x direction, I just have mg sine theta. So my Fnet is just going to be equal to mg sine theta. I'm going to plug in MA for Fnet, so I have MA equals mg sine theta, and then A equals g sine theta, as I just cancel out those m's. Okay, so not too difficult of a question here, hopefully. So let's go ahead and try a slightly more difficult question, where it says, find mu for the block to stay in place. Okay, so this asks me to find mu for the block to stay in place. So if it's going to stay in place, then I must not have a smooth surface. So I've kind of changed this. I'm no longer having a smooth surface, okay, and now it's going to be a rough surface. Remember, rough means that I do have a mu. Smooth means no mu. Okay, so find mu for the block to stay in place. And we already have our free body diagram, but in this case, we need to draw one extra force, okay? Now, we have this mg sine theta down the inclined plane, so I need some sort of force up the inclined plane to prevent it from sliding down, and that force is friction, okay? So I have friction there. So we go ahead and make our xy chart. In the x direction, I have mg sine theta again, but now I also have minus ff. In the y part, I have Fn minus mg cosine theta. Fy equals 0, which means these two things must cancel out. If two things cancel out, I have plus minus. That means they are equal to each other. So that means Fn equals mg cosine theta. In other words, the magnitudes, the amount of Fn and the amount of mg cosine theta must be the same. In the x direction, I also know that this is 0 because it's not moving. It's staying in place. It's at equilibrium. Equilibrium means the acceleration is 0. So I have same thing here, mg sine theta equals ff. Now I have mg sine theta. So the reason I don't set up f net equals 0 is this is the same as writing this. So those are two different ways to do the same thing, right? So you could do mg sine theta equals ff, or you could do f net equals 0, and then mg sine theta minus ff equals 0. But as soon as you subtract that or add that ff to the other side, it goes away, so this is fine, okay? And then our formula for ff is mu fn. We don't know fn, that cannot be in our answer. So we need to take this fn that we found over here, right? So we're going to go ahead and take this part, and we're going to plug that in. We'll plug that in over here, okay? So we'll go ahead and plug that in. So we'll have mg sine theta equals mu mg cosine theta. You'll notice that the m's cancel and the g's cancel, and we're just going to divide by cosine theta. So mu equals sine theta divided by cosine theta. Okay, and this is equal to tangent theta. Now, if you are not 100% sure about that trig identity, don't plug it in. Just leave it as sine theta over cosine theta. That's an acceptable answer. If you are pretty 100% confident, then you can go ahead and use that trig identity or any trig identity, but make sure that you're extremely confident before you're using those trig identities. So that was part 1 and 2. Let's look at the third type of forces questions. This is two-body questions. And so this is definitely where we're starting to get into much more complicated types of questions. And so there are two different types, two different ways that we can approach these problems. One is set up as one body, or two, set up as two bodies. Okay, so for setting up as one body, we're going to do something like F net equals M total A. So it's really important that the M you're plugging in here is the total M. So that's just M1 plus M2 plus dot dot dot, right? So I'm adding up all the masses we have involved, and that's going to be there. Now, for the F net, you want to make sure you have positive if towards acceleration, negative if away from acceleration. So it's really important that any force that's towards the acceleration is positive, any force that's away from the acceleration is negative. So this may mean that some of your sort of xy's are kind of flip-flopping depending on what the orientation of the object is. But you need to make sure that if it's towards the acceleration is positive, if it's away from the acceleration is negative, okay? I would still suggest even if you're setting up as a one body, drawing your free body diagrams so you can, for each individual object, so you can kind of see what's happening. But it's not, so make sure that you have that positive and negative, okay? Connecting forces. Will cancel. Okay, so any force that's a connecting force that's causing two objects to stay together, for example, tension, maybe you have something like this, two blocks attached by this string. This string force, this tension, is going to end up canceling, okay? Now, you can still write it down, that won't hurt you, but you do want to make sure that it eventually cancels, okay? Now, if you're setting it up as two bodies, you will set up an F net for object 1 equals M1A, and then you'll set up also another F net for the second object, okay? So you end up with two F nets, okay? And the way this will work is you'll always end up with one unknown being the acceleration, okay? So you'll end up with one unknown of acceleration, and then you'll have some force that's also an unknown, usually your connecting force, okay? So you have two equations and two unknowns. So that means you need to use a system of equations to solve, okay? So usually one body is a little bit easier, so I would recommend using one body, but we can go ahead and look at how both work. So let's say I have something like this. I have a table, I have a block. Let's make this smooth. Remember, smooth means no friction. Okay, let's make this a 3m block, and then over here I have an m block, okay? And it says find the acceleration. So let's first of all draw our free body diagram. And so here I have 3mg. So I would prefer that you use like a 3mg here, since that mass is 3 and not just an mg. Then we have Fn here, and then we have our tension here, this string that's connecting the two things. Now it would be important to mention that this is massless. That means I don't need to use any torque aspect. If there is a mass for this pulley, then I need to go back and use some torque stuff, but that's not what we're talking about right now, just forces for now. Okay, so it's massless. And then for this block, I have an mg. Remember, that's just mg because the total mass is m, and then I have a t up. Okay, so we're going to go ahead and try it as a one-body question first. So I have F net equals m total A. Now, these two forces do not contribute to my acceleration at all. In fact, they cancel each other out. So those are not going to be part of my F net. The only three forces I have that are going to be part of my F net is this T, and this mg. You'll notice that these T's are in opposite directions, right? Here, it is helping the acceleration. Here, it is hurting the acceleration. So we're going to have something like T minus T and then plus mg, right? The acceleration here is here, the acceleration here is here. And so acceleration means that mg will be positive, this T will be negative. Here, this T will be positive because it's in the same direction as the acceleration. Now you'll notice right here, these T's cancel out. So I just have mg. Now you do not need to write T minus T. Remember, connecting forces cancel out, so you don't need to write those down at all. I have mg equals m total, and my m total would be 3m plus ma. I have mg equals 4ma. The m's cancel, and I am left with a equals g divided by 4. So that's how you would do it as a one-body question. Remember, keeping track of the direction of your acceleration is definitely important here. Let's go ahead and try it as a two-body question. So I have an F net. This is going to be my 3ma block. And then I will also have F net and then ma. Remember, in both of these cases, the acceleration is the same. And so knowing the acceleration is the same that's sort of the key for solving these. Now here, my F net is just T because that's the only force that contributes to my F net. So I have T equals m3ma, and then over on the other side I have mg minus T equals ma. Now you'll notice I do not know T and I do not know A. So I have two equations, two unknowns, which means I can solve it. And what I'm going to do is I'm going to take this, I know that T is equal to 3ma, so I'm going to plug that in over here for my T. Okay, so I'll go ahead and have mg minus 3ma equals ma. So I'll go ahead and add that to the other side. So something like mg equals 4ma, 3 plus 1, and then m's cancel, divide by 4, and a equals g divided by 4. So both methods work, but I find that the setup as one body is maybe a little bit more intuitive than the setup as three bodies. Now, last type of question is circular circular motion questions. And the thing that's important to realize here is, how do I know it's a circular motion question, not a regular question? So, 1, you need to be going in a circle. Okay, so something's going in a circle, and then 2, speed is not changing. Okay, so generally what you're looking for is something that's going in a circle, and the speed is constant. Okay, that's not 100% hard and fast rule, but that's a good way to get at least an idea of what type of question you're looking at. So you're going in a circle and the speed is constant. Now for this, we need to remember that we have a special F net. Okay, so F net, instead of equaling MA, is actually going to be equal to mv squared over r. You'll notice here, because I have this v here, if my v is changing, I can't actually plug anything into that, and it doesn't really make sense. So here I have this special F net that is mv squared over r. Remember, this is not a force that you would label on your free body diagram. It's simply the type of F net that we are using in a particular situation. Okay. Another hint that something might be a circular motion is finding a min speed. That is also a great clue that we're trying to do a circular motion style question.